Boom, crackle, pow, splash. You hear that? We're talking about severe weather today on our lecture. Very exciting. Specifically, we're going to talk about mid-latitude cyclones, thunderstorms, tornadoes, and hurricanes. Get ready. First, let's talk about the boring sounding one first. A mid-latitude cyclone. You can probably think of what a cyclone is, which is by definition a rotating storm. But what it is by definition here is an area of low pressure. Okay, so remember, we usually see that on a weather map with an L. That is characterized by a rotating wind that moves toward the toward the rising air of the central low pressure region. All right, so basically what we have here is air rushing toward, always trying to find that area of low pressure. Something about fluids, which air is a fluid, you need to remember is that fluids always rush to that area of high to low pressure, right? So air always wants to go to the low pressure. So waves are the beginnings of low pressure system storm centers called wave cyclones. So we actually have waves of air form because of these pressure differences. Now, a lot of this will make sense on the next slide when I can have a visual for you. We call these waves wave cyclones. These cyclones influence the weather patterns in the mid-latitudes. So a little bit south of us, mainly in kind of like the prairie, kind of Midwest area. Think about Oklahoma, Kansas, Nebraska, and that area of the United States. So here's the image I was telling you about. It makes it a little bit easier to see how this mid-latitude cyclone works. Okay, so this is actually, it looks like it's forming around the Great Lakes. So here we've got a stationary front. So right there you guys can see the red and blue alternating symbols indicating that you've got warm air here, okay, cold air here. Remember, stationary fronts kind of stay stationary. They stay still. They don't move as much as a cold front or a warm front would. So winds are going in two directions, right? You got warm air going that direction, cold air going that direction, okay? Eventually, the cold air is going to overtake it because cold air, if you recall, generally moves faster. Cold fronts move faster, okay? So that wave forms because cold air is traveling faster than the warm air slightly, okay? And then eventually, as you can see here, the cold air is going to move right to the pressure difference area here. It's trying to catch up to that warm air and starts to create that cycle, that cyclone, that kind of rotating system, okay? You're going to form an occluded front right there at this point here when the cold air catches up to that warm air, right? And eventually that's not going to last forever, right? Because the two air masses are going to kind of mix and dissipate, but it's going to lose that energy. And where does that energy come from? It comes from the difference between the lower pressure and higher pressure air, okay? And this only happens when you have these two bodies of air, these two air masses next to one another, okay? And we have that air going in opposite directions at the start, all right? Big takeaway from here is that this kind of creates this unsettled weather after periods of calmer or cooler weather. So the opposite of this is an anticyclone. So unlike the air in the mid-latitude cyclone, the air of an anticyclone sinks and flows outward from a center of high pressure, okay? So instead of that parallel kind of up and down movement, we just get a sinking effect. So because of the Coriolis effect, which is the effect that governs rotation of fluids, the circulation of air around the anticyclone is clockwise in the northern hemisphere. So these storm systems will always go, clockwise. Clockwise would be, around the number of hands of clock. Anticyclones bring dry weather because their sinking air does not promote cloud formation. So for clouds to form, air needs to move up, okay? And here with these anticyclones, air kind of sinks down. So the big takeaway here is that we kind of get more settled weather. Air sinks down slowly and cools and doesn't rise up and warm and condense and form clouds. Okay, well, let's get into some severe weather. Thunderstorms are probably the most common thing that you have experienced in your own life. Thunderstorms are usually brief, heavy storms that will consist of rain, strong winds, lightning, and thunder. Hence, they are called thunderstorms. So, thunderstorms develop in three distinct stages. So the cumulus stage, right, where the clouds are building. The cumulus clouds are always cumulus clouds. They're building and building. The mature stage, that's where we have the thunder and lightning. And then the dissipating stage is as they lose their energy as the water vapor decreases. So thunderstorms need clouds, and clouds are mostly made of water vapor. So the key there is why thunderstorms don't last, long periods of time when they kind of run out of water vapor to provide more and more clouds and more essentially energy for the storm. All right, so here is a beautiful picture of a thunderstorm, not local. I have fond memories of being a kid. My dad is an amateur meteorologist himself, and would always get excited for storms and have us watch them, safely. And I think many of you can maybe relate to that and say, the storms are interesting. They're kind of an example of God or nature's power because they are dangerous and quite powerful. So here you can see the lightning produced from this thunderstorm. So it's actually lightning that produces thunder. We'll get into that soon. You can see here the thick cumulus clouds here. You're not going to see a thunderstorm produced from stratus clouds or from cirrus clouds. They're going to be those thick cumulus clouds because cumulus clouds accumulate more water vapor. So more on lightning. So during a thunderstorm, clouds discharge electricity in the form of lightning. They release electricity as the released electricity, heats the air, and the air rapidly expands and produces a loud noise known as thunder. So the heat from lightning is quite great, and that expansion actually causes that cracking sound, that loud sound. But for lightning to happen, the clouds must have areas that have distinct electrical charges. So usually how that happens is you have a cloud that has a charge, be it a negative charge or a positive charge, and then the ground would have a negative charge, right? So as this charge builds in the clouds, it wants to sort of get to that equilibrium. It's going to release that charge in the form of a lightning toward the opposite charge, right? If the ground is negative and the cloud is positive, that's where the lightning will go. And lightning is as you know, attracted to metal and things like that. So do not go golfing in a lightning storm. Super dangerous. Back to the production of thunder again. So thunder comes from lightning. So you're always going to see that lightning first, followed by the crack of thunder. And that distance in time between the lightning and thunder can actually be used to time to figure out how far away the lightning is. Kind of a cool old-time trick. Okay, so a little more lightning here. And you can see, it originates from the cloud and always extends downward toward the ground, kind of seeking a place to put its charge, put its positive charge, right? And quite beautiful too, but you don't want to be struck by it for sure. Hurricanes. Hurricanes are severe storms that develop over tropical oceans, okay, whose strong winds. So again, just go back a second. Tropical oceans, just a side note, that's warm oceans, okay? So we're not talking about Lake Ontario. We're not talking about the Arctic Sea. The Gulf of Mexico is what we're talking about. We're talking about the South Pacific. We're talking about Indian Ocean. We're talking about warm bodies of water, okay, whose strong winds of more than 120 kilometers per hour spiral toward the intensely low-pressured storm center. So this number, 120 kilometers, is key for determining if it's a hurricane or not. So translate that to miles per hour. I believe it's over like 60 miles per hour or so, 65 miles per hour or so. That is the cutoff for if it's a hurricane or not. If it's not up to that speed, 120 kilometers per hour, it's known as a tropical storm. And before that, a tropical depression. But it's got to get up to that point to be officially considered a hurricane. And again, we see air again low going toward the low pressure. And that's what the center of the storm is. It's an area of low pressure. A hurricane begins when warm, moist air over the oceans rise rapidly. Remember, when air rises up, that's when we get cloud formation. So when a lot of that air goes up, we get a lot of clouds. So when the moisture in the air, rising warm air, condenses, a large amount of energy in the form of latent heat is released. The heat increases the force of the rising air. So this kind of warm water, this is warm water here, just adds more and more energy, and this latent heat causes the clouds to rise up even faster and create more clouds. So it kind of this compounding effect. So the heat released from the warm water makes more clouds, and more clouds kind of build up and slowly build into a hurricane. A fully developed hurricane consists of a series of thick cumulonimbus clouds that spiral upward around the center of the storm, called the eye. We'll have a good picture of that in a second here. The most dangerous aspect of a hurricane, most people think is the wind, maybe or thunder or lightning, but it's actually rising sea level and waves called a storm surge. Those bring debris, those pollute lots of oil and natural gas and things in the water and cause that long-term damage. Hurricane Katrina, we're going to discuss a bit in class. The real problems came from the destruction of the infrastructure of the city, the disease that the water brought, and to a person, you can kind of hide from the wind a bit in a structure, but you really can't hide from a great amount of water rushing toward you. It's going to bring shrapnel and sharp things. It's super, super dangerous. So here's just a satellite image here of the hurricane. You can see the eye there. So in this area here where I'm circling, that's the extremely low pressure air, right? So that low pressure air, all this air around it, the surrounding air is rushing to try to get into that low pressure center, right? So that's what's causing the rotation of the storm, is that air moving toward that. You can see all the cumulonimbus clouds around it. These are called bands here, these bands of clouds. And here's an example of that storm surge, right? So you have, this is probably a smaller example here, but you have the ocean waves pushing up into the community here and overtaking seawalls and causing major catastrophic damage. Next, we're going to talk about this. So what is this here? This is a tornado, all right? So tornadoes are pretty classic, and this is kind of where you see them, right on the farmlands of the prairie. And we'll talk about why that is in a minute. But tornadoes are these columns of air, right? So a hurricane is a huge, wide area, often 100 kilometers or more touched by the storm. But here, you're just talking about a kind of smaller local area. And these are super dangerous, but they don't cover as much of a path that a hurricane does. But pretty cool. I'll never forget seeing one form with my dad in Canada when I was a kid on the way to Detroit. That was a cool experience. We kind of watched this thing go all the way down and touch the ground and kick up a bunch of debris, and that was pretty neat. It went away quickly, but it was a good memory. So what is a tornado? It's a destructive, rotating column of air that has very high wind speeds and that may be visible as a funnel-shaped cloud. And a key here is rotating column, okay? The smallest, most violent, and short-lived severe storm is a tornado. So we're talking about the highest wind speeds and the most destructive, if it touches you, would be the tornado. So tornado forms when a thunderstorm meets high-altitude horizontal winds. So when you've already got a thunderstorm, right, and then these high altitude winds kind of supercharge it and add a bunch of energy to the storm. So these winds cause the air in the thunderstorm, which is already rising up, right, collecting more moisture to start to rotate. And that rotating wind creates a super low pressure column of air. Okay, so If the funnel does touch the ground, it can kind of wander around and cause a bunch of damage haphazardly. So how do they get so powerful? The destructive power of tornadoes due mainly to the speed of the wind. So these winds can be more than 400 kilometers per hour, over 200 miles per hour, and they bring a lot of debris with it. Can just lift things up and carry them away. Like those things you see on movies is quite accurate. It can pretty much move huge masses and causes tons of damage. So you want to get, in a low place, in a basement or a shelter, and stay out of an open area for sure because of all that debris. They're not too common here. They're very rare here, mainly because we don't live in that kind of mid-latitude, which causes has these big, huge air masses forming the storms. You're generally going to find them in Oklahoma, in Texas, in Kansas, Nebraska, kind of that they call that tornado alley. I'm going to show you guys an image of that in class and when we talk about it a bit more. Actually, pause that. I'm actually going to show you guys an image of tornado alley really quick in the next slide. So tornado alley is kind of the places, locations you see here. It is along the Midwest here. You can see that right in that middle part of the country here. And why is that? Well, you got warm tropical air coming up from the Gulf of Mexico. You've got weather systems coming from the west, and they kind of meet there and collide, and they form this area where you're going to find most of our country's tornadoes. Just look at that. That's that one little band right there. Is where they all happen. So if you ever get a chance to see one, super cool. Hope you're safe and don't stay too long to watch it. But they're pretty rare for our area. Hope you enjoyed this lecture. It wasn't too long, and get ready for a short quiz and have a great evening. And watch out for that severe weather.